All right, in this video, we're going to talk about trig function values at any angle on your four quadrants here. The big idea is, and we've talked about it before, a trig function will have the values, right? If I have an angle here, we'll call it theta, that's our central angle. If I have an angle on a triangle, I can draw that triangle out into any quadrant, and if I know the x and y coordinates, well, basic idea is the sine of theta will just be its opposite, so typically our y coordinate. Since we're always going to draw our angle or our reference angle down to the x-axis, the opposite will always be the height. The adjacent will always be x, so when we talk about cosine, again, much like our unit circle, sine is y and cosine is x, only now we're not on a unit circle. Notice that our radius is r units wide, right? R units. It's not necessarily 1 unit, which just means we need to say opposite divided by hypotenuse, right? What we'd call the radius of that circle formed by drawing a circle centered at the origin, but again, through point xy, right? The tangent would again be opposite over adjacent, so we'd call it y over x. Cosecant is the reciprocal of the sine. Again, the cos don't go together, right? So cosine has to go to secant. We would call that r over x. Cosecant is r over y, right? The reciprocal of the sine. And of course, cotangent, reciprocal of the tangent. Now, knowing those trig values, I would definitely write those down. Knowing those trig values for any point on a graph, we can use that to help us if we are given a random point. So notice here, an angle theta in standard position has a terminal side that passes through the point 5, -2. So let's just imagine that this is 5 and this is -2. And again, I'm going to draw a point here. What we're saying is we've got an angle that's formed by going from the origin through that point, right? And again, theta is going to be the angle formed. So theta is going to be technically this angle, right, formed all the way around. Now, when we represent our triangle, though, again, we're always going to look at the reference angle, what we often call, right, reference angle. I'm going to call that theta prime. So that would be this blue angle I'm drawing here. This would be theta prime, right? And again, I can draw that right triangle in that fashion. Knowing that we went right 5 units, I know that my leg is 5. Knowing that we went down 2 units, I know the other leg is -2. Very quickly, we need to know that hypotenuse. I'm going to need to know that length. That's not a 1, right? Because we're out 5 and -2. That's definitely longer, right? The length from here to our point, forming that triangle. So we better say 5 squared plus -2 squared is going to be equal to, and again, let's call it radius, as though we had sort of drawn a circle around there, going through that point, the radius squared. So 25 plus 4 is going to be 29, equal to r squared, and r would be the square root of 29. Now that can't really be reduced. 29 is a prime number, so luckily we don't have to break that down at all. But if you do, remember, simplifying is always a good idea. Sometimes that means we might be able to reduce our fractions. But in that case, sine of theta then, right, or sine of theta prime for that matter, is going to be the opposite, again, the y coordinate over the hypotenuse. And again, we should rationalize real quick, multiply the top by root 29, and multiply the bottom by root 29, turning it into just 29, and we get a nice value there. Cosine of theta, right, would be adjacent over, again, hypotenuse, or basically, again, multiply the top by root 29 and the bottom by root 29. Root 29 times root 29 being 29, right? And then finally, the tangent of theta, opposite over adjacent, or basically y over x, right? Technically, we didn't even need the picture, right? The picture helps us represent that hypotenuse. But again, technically, if I was looking for the tangent, I knew what x and y were when we started. And remember that our definition from the previous page is that the tangent of theta equals y over x. Or essentially, sine over cosine if we were on a unit circle, right? If you divided these two values, though, if you divided the sine by the cosine, all that would really happen is those denominators actually would end up canceling away, right? Multiply by the reciprocal, those disappear, your root 29s would disappear, right? And you would just end up with -2 over 5. So notice that's sort of what would happen, right, if we followed that idea. We don't need to do that though. We've got the nice picture to judge it from, so that always works. Finally, what else these definitions can help us with? Well, again, it's really easy when we can draw that triangle to kind of judge the opposite over adjacent and things like that. But what do we do if we're at a quadrantal angle, right? What if we're talking about cosine at 180 degrees? Well, what if we take our picture, 180 degrees, again, is going to be right on the quadrant over here. Well, in that case, I can't draw a triangle. I don't have a reference angle to work with, right? I'm already on the axis. So the cosine at 180 degrees, well, that's going to be a little tricky to do. Now, if we judge it off of a unit circle, because it really doesn't matter the length we go, right? Now we'd be saying r equals 1. But if we go to 180 degrees, what we're saying is we're going to go to the left 1 full unit. So essentially, again, r equals 1. Well, we know that the cosine definition, remember, was x over r. Well, for us, our x coordinate would be -1. We went left 1 unit. And our r value, right, our circle has a radius of 1. So I can tell you right now the cosine at 180 degrees is going to be -1. Again, those definitions we had before, right? Sine being the y coordinate, or y over 1, since r is 1 this time. Cosine, again, just being x. And again, our other values also working out there. Again, this chart works really well when we think about r as 1. Now, if r was greater than 1, all we would have to say is that, again, y over r, x over r, and all of these 1s, right, would turn into r's. Well, sine at 7 pi over 2. 7 pi over 2, 2 goes into 7 3 full times. So again, we're thinking 1 pi, 2 pi, 3 pi, and an additional half pi. I'm thinking we're down here at the bottom of our screen. So again, sine would be the y coordinate. Again, it would be that -1 over r. So again, the sine at 7 pi over 2, or the sine down here, right, at 270 degrees, -90 degrees, however you want to think of it, the sine of the negative y-axis, essentially, is going to be -1. Cosecant at 90 degrees, again, 90 degrees, we're looking up top here. So we're looking at 0, 1. It wouldn't be a bad idea just to kind of think about that, draw that out, 0, 1. Well, again, cosecant is reciprocal of the sine. And again, that means that we're r over, right, the y value. Well, remember our y value up top there would have been 1. So again, that also is going to be 1 over 1. Cosecant at 90 degrees will have a value of 1. Secant at -3 pi. Again, we'll go around our circle, right? 1, 2, 3 pi times, right? So again, we're going to be over here on the left. Secant, again, being the reciprocal of the cosine. So we're going to be r over x, r being 1, x being -1 over at that, we went to the left. So again, we're -1. Now, you won't always get 1 or -1. Tangent at 270 degrees, well, again, if we're down here at the bottom, 270 degrees, tangent is y over x. So that's where -1 over 0, well, we're going to be undefined, right? It's going to be an undefined value down there. And then finally, tangent at pi, right? We're over here on the left. Again, same thing, y over x. Well, this time we would flip those numbers around, and we get just 0. Realize that the quadrantal angles, though, a lot of times you're either going to be a 1, you're going to be a -1, or else you may be 0 or undefined. Make sure you work that out, again, using those coordinates, because we're not going to be able to draw a right triangle for those quadrantal angles. If you have any questions about that, or, again, the previous problems of finding a trig function at any angle in any quadrant, make sure you talk to your teacher. Otherwise, have a great day.